Everybody, we are back. We are starting into chapter 9. We are on 9-3. This is solving quadratic equations, and we're talking about roots. And roots can be found two different ways. They can be found graphically, actually calculate. And in that method itself, roots, yes, you're going to be using square roots, the exacts. Yeah, it's kind of a math. We give away what we're doing with our answers. So let's get into this. Remember, we're going to be solving this equation, ax squared plus bx is 0. And a is 0. If a is 0, we have b squared. Well, quadratics because we have an x squared. So we can't make that x squared disappear. So a always is going to be something other than a 0. Now, this is standard form for quadratic. Easily identify a, b, and c. Quadratics can be solved many ways, like we just said. Today we are diving into the root method, both graphically as well as computationally. We have to remember in math a lot of terms mean the same thing. So zeros, solutions, all of these all flow down to x-intercepts. Or in other words, when I equals 0, what is the value of x? Or f of x, remember, f of x is the same thing. This stage, the one is just hey, as we start to look at this graphically, right, here's a few graphs that we have. It is very important to look at key aspects of graphs. We want to look at, where do they intersect? X intercepts, Y intercepts, they're all key points. But today, our roots, our solution, when they give you a graph, our only purpose we do when we look at a graph like this and they ask us for, we're trying to see where does this graph touch the x-axis. So in this case, we don't need that. We need those 2 points. Those are the 2 points that graph intersect the x-axis. So those would be our solutions. Our roots, which would be -1 and 1. This has 2 solutions. And this is all this is. Again, you guys always say 8 graphs. Man, graphs are easy. They literally are giving us the answers there. They are cheat sheets. Okay. Look at example 2. Look at this quadratic graph. And this time, only 1 point touches, because we could have 1, 2, no solution to a quadratic equation, depending on whether and where the graph touches your x-axis. Take a look at this. It's only one solution. At 1 point, it's the vertex. So right there, the vertex touches at 0. There is only one solution to this equation. What else they have for us? Again, quadratics can have 1, no solutions, also known as zeros, solutions, x-intercepts. All of this means the same thing. Where does this graph touch the axis? Nowhere. It doesn't touch at all. So there are no real solutions to this particular graph. This is a complex situation, so we have complex answers. Don't worry about it right now. In algebra 1, we know there's no solution, real solution to this particular equation. Again, kind of solution. We have 2 like the first example, one like the second, or none like the last. Now, getting into the computational part of this, the actual, we need to solve. Our goal is we are trying to solve for m. This method is best when you notice that b is 0. When there is no middle term, when there is no power of 1, the exponent, middle term is gone, b is 0. A is 1, b is right there, 0. b is -36. This method is the best and fastest to solve. I'd also sometimes look, could have factored this special case factor. Let's just see how the See if we get the same answer. Okay, look, we need to solve for m. M is trapped in the square. So we need to move this 36 to the other side. Right out of chapter, solve for add 36 to both sides. Property of b. Then what do we do next? Well, we are trying to get rid of a square. You got to remember reciprocal properties. The reciprocal of a square is a square root. So we have to take the square root here. And the square root cancel the square, leave us just an m. When we go to take the square root on the other side of a positive number, right, we have to take plus or minus square root of this side. I'll explain that in a second, right? So what is the square root of 36? If you use your calculator, great. If not, you should know that our perfect square. Like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 144. All the numbers multiplied by themselves. 6 times 6 gives you 36. Also do a plus or minus here, because what else would equal 36? Negative 6 times negative 6. So this is plus or minus 6. That will account for both positive and negative. It could total that 36. And like that, boom, you solved this equation. You know your solution M is actually could be 2 possible answers. If your computer gives you the plus or minus key, you can hit that in a 6. Or you can separate your answer using a comma. Solution set would have a -6 and a 6. Most of our computers, though, now do have the ability to do that plus or minus. Okay, for example, that was example 4. Example 5. We go and solve this. All right, so we're solving again for x. Track both sides. Write everything else down. And what do we do? Divide by 3. Divide by 3. Cancel. Get a -5. You got to get rid of the square, so we take the square root plus or minus the square root of this side. We got an issue. If you put in your calculator the square root of -5, there is gives you an error. There is no solution here, no real solution to this one. Can't take the square root of a negative number. Not hard, not bad. I mean, this should feel a lot more very similar to what we did in chapter 2, but with adding square roots. This one starts to get bigger, right? Doesn't matter. We have to start to do the same thing we did. Our x is trapped in a set of parentheses, which is being multiplied. This is all one term. Get rid of the one first. -4 equals 4 times x squared. Well, to release this, we have to divide by 4. -1 equals, now these cancel, and x squared is 10. We can go ahead and add 10. Feel just like way back when, chapter And last step, to get rid of this, take the square root. We're going to take the square root of a positive number. You must account for both positive and negative possible values, plus or minus 9. So that's plus or minus equals x. Not so bad. We're rolling through this. Here we go, more examples. And it's good just to see examples. I'm going to talk a little less, and you can watch as I work them out, okay? Subtracting 16 sides. Oh, I did myself a lot, especially when I do math. Helps. Carry down. Divided by 4. So we're looking at this, and we're like, uh-oh. What do you mean, square root? I'm going to have to take the square root. Take the square root of 0, plus or minus 0. Put in your calculator. What does it give you? It says, please cancel. It gives you just 0. Notice I don't bring the plus or minus down. There's no such thing as plus or minus. You have one solution. Your solution is 0. It only touches that x-axis one spot at 0. So the vertex is what touches your x-axis. Right? I will keep working out. Now, if we see a star by one of these problems, we're going to leave our answer as a radical. Maybe we're not getting a perfect square. So we don't want to estimate and try to leave things exact answers unless it tells us put things as decimal. Here we go. We're going to do this one again. So this is a little bit of a bigger problem, a little slight difference here where our squares are. So let's be careful. We're going to subtract 3. Left 125. And divide by 5. Right? So 125 divided by 5 gives me 25. Canceled, and now I only have x minus 2 squared. This is where it's slightly different from the problems up above, right? I need to take the square root of this whole thing. Minus the square root of this. I have plus minus a 5 equals that, cancel that, and I'm left with an x minus 2. I write this one slightly different, just so we can see. Change color. I need to get rid of this 2, so I'm going to add 2. If I add 2 to one side, I have to add 2 to the other side. It's just set up so we can see it maybe what's happening. I can cross these off. X is equal to 2 plus or minus 5. Guys, this is actually 2 separate problems, right? This is 2 plus 5, which is 7. It's also 2 minus. Negative 3. There is your solution. 7 and negative 3. Be careful with that. That would be tricky. First time you've done it, but we'll be doing a lot of these. Here's the star, and on our star, it's asking us, we're going to remember, in radical form. So let's see what this one looks like. Start the same way we just did. I'm going to add 1. We have 6. A lot of this work is just carrying everything down. So be careful. I've got to divide by 2. Okay, 6 divided by 2 is a 3. Cancel. X plus 3 in parentheses square. Now, get rid of the square. I have to take the square root minus the square root. What you're going to notice here is that we cannot take the square root of 3 and get a nice pretty number. You get some decimal. So just leave it like this. Equals x minus, plus 3. Carry down exactly, because that only is plus 3. Last step, you have to subtract 3 from both sides. And since we're leaving it in radical form, this is actually less work for it. You'll type it into your computer just like that. Right? That's not bad. Let's look at one more just like that. Okay? Again, you need to subtract 1 from both sides. This time we have the square root plus or minus the square root of 13. Again, 13 is not a perfect square. This is going to stay looking like a radical all the way to the end. That canceled that and left us with 2x minus 5. So add 5 to both sides. Right? We have 2x is equal to 5 minus square root of 13. X is still not alone. Divide by 2. Divide this entire piece by 2. Like that. This becomes our final answer. X equals 5 plus or minus the square root of 13, all divided by 2. All right, guys, this is really stretching and practicing. It's expanding our knowledge on how to solve equations that now includes multi-steps with radicals and all this fun stuff. When you're doing radicals, that's what causes you to have answers, that plus or minus, that when we take the square root of a positive number, count for that positive possible negative result. If that number under the radical is not a perfect square, leave it in radical form. Your answer's that. All right. Have a wonderful day, guys. Get out there and do that homework.